Okay, so Chapter 3, Tro Chapter 3, Section 2. Again, we're going to be probing the meaning of molecules in Chapter 3. And in order to do so, we're going to consider chemical bonds. So there are, most textbooks will say three kinds of bonds. Tro is only going to deal with these first two here, but I put a third mention here just in case anybody's wondering. So first of all, and I'm not even going to talk about what it is, but there is another kind of bond, and we're going to leave that as a big question mark in your mind. So chemical bonds. First of all, ionic bonds, and then covalent bonds, and then, as I said, the other kind. So an ionic bond is formed when you have two atoms. First of all, let me go back here to pencil. We have a metal here, right? And a nonmetal. And you recall, I think it's page 55, might be somewhere around there. You recall from a previous section that nonmetals have a tendency to gain electrons, and metals have a tendency to donate them or to lose electrons, right? So here you've got a metal, and can you see an electron is going from the metal to the nonmetal, so the metal's losing an electron, and the nonmetal's gaining the electron, and when that happens, chlorine becomes chloride, and it's a Cl minus, which you can see right here. And sodium, because it lost an electron, is left as a sodium ion, right? So now these two ions are attracted to each other, and by virtue of their electrostatic attraction, they associate with one another in a lattice, right? So with sodium in a metal lattice, you have these, array of atoms. And over here in chlorine gas, that's what that looks like, right? So if you take this sodium metal, which is sort of a soft silvery metal, and you could look really closely, you would see, obviously very, very closely, this is sub microscopic, you'd see these atoms. They're not purple, but we make them purple to help you see what's going on here. And it's an array of, three-dimensional array of atoms. Over here in chlorine gas, it's a bunch of diatomic chlorine atoms that are bonded to each other, right? So when these guys come together, sodium donates an electron to chlorine, they become Na+, Cl-, and then they end up in a three-dimensional array, as you see here. Okay? So that's the formation of an ionic compound. And to recap, metals have a tendency to lose electrons, and I'm going to put a little note here, something that your book does not have. To nonmetals, can you read my writing? And nonmetals have a tendency to gain electrons. Can you tell what I'm going to say here? From metals. These become cations, these become anions, and the attraction between cations and anions is called an ionic bond. I take exception to that. It's not really a bond, right? It's an electrostatic interaction, but we are going to call it an ionic bond. And some of you are not going to like that because you're saying to yourself, wait, it's not a bond. But either way, let's call it an ionic bond for now, and if that doesn't make any sense to you, let's probe this concept, and it'll make more sense later. Let's consider what happens when covalent bonds are made. So suppose that you've got two nuclei here, which I have indicated with plus signs, right? Here's two nuclei, and suppose you have an electron in between them. Well, the lowest potential energy or most stable place for this electron is going to be right between it, right? Can you see that? That the closer this guy gets to the negative gets to that positive, the happier he is, and the closer he gets to that positive, the happier he is, right? So right between them is going to be the most stable position. Over here is not as close as it can be to both of them. Over here is not. This is the best. Okay? And this is how covalent bonds are made. You might have a valence electron, an electron that's sort of associated with this atom, and then that electron, though, when it comes around and it ends up being in between the two of them, it ends up being valent electron for that one too, right? So that electron is shared. I guess that's the critical word here. I would say is shared. And when it's shared, it's going to be right between them, and that electrostatic interaction we're going to call a covalent bond. And we're going to say much more about this in this chapter. So in review, covalent bonds are made between nonmetals and nonmetals, and they have a tendency to share electrons, right? So we saw before that when nonmetals and metals interact, they have a tendency to donate, but in the case of nonmetals and nonmetals, they have a tendency to share. The shared electrons are localized between the atoms, and that's called a covalent bond. Molecules are made up of atoms that are covalently bonded to one another in a fashion as I described in the previous slide. Okay? And as I promised before, there is a third kind of bond, and I'm not even going to mention it. You might, if you're curious, consider going back through these slides and saying, hey, what's missing? I sort of implied I think you could derive from what I said that something's missing. I really can't say much more than that. Okay, hope that's helpful.